Good morning and welcome to section 4.1, max and min values, day 2. Yesterday, or in our last notes video, we went ahead and looked at visually where do max and mins occur. Today we're going to go ahead and use calculus to figure this out. So, the first thing we need is critical numbers. Critical numbers are where a max and min can occur. Okay, so what we need to do is find critical numbers. Critical numbers are where you take your first derivative and set it equal to 0, or it is where your derivative does not exist. Okay? The reason this is let's just think about it. We did a little bit yesterday. If you look here, you should see my tangent line has a slope of 0, which is a maximum. So that's why we take and set our derivative equal to 0. Okay? Same things can occur when derivatives don't exist. Okay? So that is why we're doing that. So the first example, we're just going to go ahead and find our critical numbers. So take our derivative, set it equal to 0. So the first thing we're going to do is simplify to make life easier. So f of x is equal to 4x to the 3/5 minus, this is to the first, so 3/5 plus 1 is 8/5. So x to the 8/5. Now I'm going to take the derivative of this. So then I will bring down the 3/5. 4 times 3/5 will give us 12/5 x to the 3/5 minus 1, negative 2/5. And then we take the derivative of this, so minus 8/5 x to the 3/5. Okay, so there's our derivative. So what we need to do is go ahead and set that equal to 0 and figure out where it doesn't exist. Okay, so in order to do this one, we're going to have to rewrite our derivative. Okay, so we are going to put our negative exponents in the denominator. And then this should be in the numerator because it's positive. And then the other thing is I look at it, and in order to actually figure out where we don't exist and to set it equal to 0, we're going to need a common denominator. So let's get a common denominator. This has a 5, this has a 5, this has a x to the 2/5, this one does not. So we got to multiply x to the 2/5, which actually is going to make things a little easier for us. So our first derivative will be 12 minus 8, and here's where the nice part comes in. 3/5, x to the 3/5 times x to the 2/5. 3 plus 2 is 5. 5 over 5 is 1, so minus 8x. All over 5x to the 2/5. Okay. So there's our first derivative. Now let's find our critical values. So the way we do that, take our first derivative and set it equal to 0. So we will have 12 minus 8x over 5x to the 2/5 equal to 0. If I multiply both sides by 5x to the 2/5, okay, it will cancel. So let's do that. These cancel, so I have 12 minus 8x is equal to 0 times that, which is 0. Okay, I'm going to add the 8x to the other side. So, and then divide by 8. So x equals 12 over 8, which is 4 over 3. No. 4 over 2. 3 over 2. There we go. 3 over 2, or 1.5. So one of our critical values is x equals 3 over 2. Then we always have to go ahead and also double check. Is there a place where our derivative does not exist? Okay, we're looking for where this could happen. Most of the time comes from our denominator. So here's our derivative, and if we see our denominator, if there's an x with it, chances are there's a number that would make it not exist. So in this case, I would divide both sides by 5. 0 divided by 5 is 0. Then to get x by itself, you take it to the 5/2. Right? Because 2/5 times 5/2, 2/5 times 5 over 2 gives us 1. So x to the first is equal to 0 to the 5/2, which is 0. Okay. So this leaves us with our critical values of 3 over 2 and 0. So critical and 3 over 2. That would be our answer for this one. So critical numbers, critical values, same thing, but take your first derivative, set it equal to 0, and also where does your first derivative not exist. Okay. So closed interval method. Okay, well, it has to be a closed interval. And the function must be continuous. Okay, if we have a continuous function and it's on a closed interval, we can find the absolute maximum and absolute minimum values using this method. Remember, absolute means that it is your absolute biggest or absolute smallest y value. Okay, so what we have is, to do this, you first find your critical numbers on that interval, and then you also find your endpoints, which are given to you. These are your endpoints. And then what you do is you plug your critical numbers and your endpoints into your original function, and then whichever one's the biggest, that's your max. Whichever one's the smallest, that's your min. Okay, I should say absolute max and absolute min. So example 2, find the absolute max and min values of the function. So first things first, let's go ahead, find our critical numbers. So that is when you take your derivative. So we have 3x squared minus 6x. And then we have to take our derivative and set it equal to 0. That's one way. So I have 0 equals 3x squared minus 6x. To solve this, I would factor out a 3x. So what do I have? X minus 2. Then I would set them each equal to 0. So if I divide by 3, x will equal 0. And if I solve this one, x equals 2. So those are my first two critical numbers. I also must check if there is a place where my derivative does not exist. Okay. Well, it's a polynomial, so in this case there is none. But always make sure you check. Okay. If there was a fraction, a square root, you can't plug negatives in a square root. Those are the things that we're kind of being cautious of. All right. Then what we do is we take our critical numbers and our endpoints, which in this case, our endpoints are -1/2 and 4. And we check, are these critical numbers in our interval we're looking at? Is 0 in between -1/2 and 4? And is 2? Yes. Then we plug them, all 4 numbers, into our original function. Okay. So we are finding, make sure I have enough room here. I like to go in order. So our smallest number is -1/2. Then we go to 0. Then we go to 2. And then we go to 4. All right, I do not have access to my calculator right now, but what I would highly, highly recommend is you go to your graphing calculator, plug this function into your y equals, then go to your table set, which is above, one second. Remember, table set is above your window. And make sure that your independent is set to ask. Okay, independent, set it to ask. Change it to ask. And then if you go to your table, which is above graph, then you can just go ahead and say, I want -0.5, and it tells you the number. 0 tells you the number. 2 tells you the number. That is what will make it the easiest. But you don't have one, you're going to just type it all in. So you're going to do, for f of -1/2, I'm going to write it out, and then I'm just going to tell you the rest of the answers. So if I plug in -1/2, you would type parentheses, that's not what I wanted, -1/2 to the third minus 3, -1/2 squared, plus 1, and you get out a number which is 0.125. Okay. Then you plug in 0, that one's easy. You plug it into your original, you get out 1. Plug in 2, you get out -3. And you plug in 4, and you get out 17. Okay. So you take your endpoints and your critical numbers, and you plug them into your original, and then you just go ahead and look. Who is the biggest number of my y's? Well, 17. So guess what this means? This is my absolute max. Okay. So our absolute max is, there's a few ways you can write it. It is 17 at x equals 4, or I'll even let you say it's at 4, 17, the ordered pair. Then you go ahead and find the smallest number, which would be right here. This is your absolute min, and then you'd write that one out. Okay, absolute minimum. You could say it's -3, at x equals 2, or you could write it as an order pair, x comma y. But this would be your answer if I ask you to find your absolute min and absolute max values. All right, example 3. We're not going to do the graphing calculator, but we are going to use calculus to find the exact minimum and maximum values. If you don't have your solar yellow sheet out, you might want to grab it just because we're going to use the unit circle. So it says use calculus. So first things first, take the derivative. The first derivative is derivative of x is 1 minus the derivative of 2 is a constant, and then the derivative of sine will be cosine. Okay. So there's that. Now we go ahead and say, does my derivative never exist? Is there a time? It does not exist. No, it always exists. And then we also go ahead and take our derivative and set it equal to 0. So our derivative is 1 minus 2 cosine of x equals 0. So we're going to get cosine by itself. So I would subtract 1. So I have negative 2 cosine of x equals negative 1. And then divide by negative 2. So we're really looking where our cosine is 1/2. So cosine, if we're looking on our at our unit circle, there are x values. And it's where I want a positive 1/2. And so we're looking in quadrants 1 and 4. And if I look here, cosine is my x. We want a 1/2. So we're going to have pi over 3. And then if I go straight down, 5 pi over 3. So my x values, or my critical numbers from this, are x equals pi over 3 and 5 pi over 3. Okay. Now what we need to do is we take our endpoints and we check, are the critical numbers we got in our interval from 0 to 2 pi? Yes, that is correct. Okay. And so we're going to check all of them, our endpoints and our critical points. Okay, so we have f of 0, f of pi over 3, f of 5 pi over 3, and f of 2 pi. So what we have is 0, since x is 0, minus 2 times sine of 0. So sine of 0, if we look at our unit circle, we go to 0, your sine value is your y value, so that is 0 right here. Okay, so we really have 2 times 0, so this gives me a value of 0. Then we have pi over 3 minus 2 sine of pi over 3. So we have to be careful because it does want the exact answer, right? Exact max and mins. So you'd have to look sine of pi over 3, so we go to our unit circle. Pi over 3 is here. My y value is square root of 3, comma 2. Sorry, square root of 3 over 2. So we have pi over 3 minus 2 times square root of 3 over 2. If I simplify, these will cancel. So we really have pi over 3 minus square root of 3. That's my exact answer. Okay. So we got 0, we got this. Now I got to plug in 5 pi over 3. So I have 5 pi over 3 minus 2 sine of 5 pi over 3. Once again, look at our unit circle. 5 pi over 3 right here is negative square root of 3 over 2 for my sine value. So negative. So it's negative 2 times negative square root of 3 over 2. These will, once again, the 2's will cancel, but negative negative makes it positive, so my exact would be 5 pi over 3 plus square root of 3. And then the last one, we got to plug in 2 pi. So we have 2 pi minus 2 sine of 2 pi, which we know 2 pi, sine of 2 pi is 0. So 2 times 0 is 0. So I get out 2 pi. All right. So this is all good, and it wants exact, so you're going to have to write out your answers with the exact. But we need to determine, okay, we got 0 here, and we got 2 pi, which is 6 point something, right? So you might want to, on your calculator, type in to get a rounded answer to think about it, okay? To think about which one would be the best, or which one is the answer. So I'm going to type in, because I don't have my answer key here, pi divided by 3 minus square root of 3. This one gives me negative 0.685. Okay. Let's go ahead and do the next one. We got 5 pi divided by 3 plus square root of 3. That's going to give me 6.968 for this one. And then 2 pi is 6.283. So remember, we're doing absolutes, so we're looking for the biggest number and the smallest number. Okay, so my biggest number would be this one. And then my smallest number is this one. So my absolute max, I'm going to write as an ordered pair this time, is 5 pi over 3, comma, 5 pi over 3 plus 3. Looks funny, but there it is. Then my absolute min, we would have pi over 3, comma, pi over 3 minus square root of 3. There it is. Oops, drew right through there. Those are my absolute max and absolute mins. Okay. Good. All right. Solve analytically to find the extreme values on the interval negative 1 to 3. So analytically means just using calculus, no calculator. So we got to find our extreme values. Extreme values are your highs and your lows, so your absolute max and your absolute mins. So step 1, take your derivative. So we'd have 2/3 x to the negative 1/3. And we're going to have to rewrite this, so I'm going to rewrite it right away. So we have f prime of x equals 2 over 3x to the 1/3. Okay. Now we go ahead, set our derivative equal to 0. So I have 2 over 3x to the 1/3 equals 0. If I times both sides by my denominator, I would have 2 equals 0. Can 2 equal 0? No. So this one actually gives us no info. Okay, no info this time. But then we also have to be worried about when does our derivative, when it does not exist. This time I see I have a fraction, so I'm going to take my denominator, right? That's what we're worried about, and setting it equal to 0. We divide both sides by 3. 0 divided by 3 is 0. And then I would take to the 1/3 power on both. Or sorry, not 1/3. How do you undo 3? The reciprocal. How do you undo 1/3? You do the reciprocal, which is 3. So these cancel. So x is equal to 0 to the 3rd, so 0. Perfect. So 0 is a critical point. I don't have any here, but I have this one. This is a critical value. So I would just make sure, is this critical value in my interval? Yes, it is. Okay, so that's good. So now I'm going to go ahead and check my endpoints and my critical value. So I'm plugging in -1. I'm going to plug in 0. And I'm going to plug in 3. All right, so if I plug in -1, okay, -1 to the 2/3 gives us out 1. If I plug in 0, get out 0. If I plug in 3, this one looks a little funny. We want to stick with exact answers. It is really saying the cubed root of 3 squared. So it's the cubed root of 9, which you can't do, okay? You can do, but sorry, it's not a perfect cube root. The cube root of 8 is, but not the cube root of 9. So I'm just going to get an approximate estimate to what is the cubed root of 9. So we have 3 to the 2. So if I'm looking for the numeric answer, this is approximately 2.080. Okay, this is 0, this is 1. So we got to figure out who's the max, who's the min. This would be our max. This would be our min. So we write it out. Absolute max is the 0.3 comma cubed root of 9. And then my absolute minimum will be 0, 0. And there are my absolute max and absolute min for example 4. Okay. same thing here. Solve analytically. So using calculus to find this derivative. So we go ahead, take our derivative, chain rule. Ooh, chain rule. Out in, so we got ln of x, and we got x plus 3. Derivative of ln of x is 1 over x. Derivative of x plus 3 is 1. So we're taking this, plugging it in here, and multiplying by 1. So it's 1 over x plus 3. Okay, so now we have to take our derivative and set it equal to 0. If I times both sides by x plus 3, they'll cancel here, so I'll have 1 equals 0 times x plus 3, which is 0. 1 does not equal 0, so in this case, once again, this gives us no values or no info. Then we just have to ask ourselves, where does our derivative does not exist? I see it's a fraction. I see I have a variable in the denominator, so I have to say what number can I not plug in? So I set it equal to 0. So x will equal -3. Okay, can't plug in -3. -3 plus 3 will be 0, and you can't divide by 0. So then I check, is -3 in my interval? No, it is not. So I actually don't even need to test that point. You have to show, but it's not in our interval. So not in interval of -2 to 2. So don't plug in. To f of x. Okay, so that means we just have to check our endpoints. So we're going to do, let's see, f of -2. So we have ln, it's -2 plus 3. -2 plus 3 is 1. ln of 1 is 0. If you type it into your calculator, you'll see that. f of 2 equals ln of 2 plus 3, which is ln of 5. And if you type that in, it's not going to be a nice answer. I'm just going to write it down. But it is approximately 1.609. Yep. So who is the max and who's the min? So our absolute max, the biggest one, is the ln of 5. So we'd have 2 comma ln of 5. And then our absolute minimum is the smallest number, which is 0. So -2, 0. There is example 5. All right, example 6. Same idea, find analytically to find all your extreme values on our interval from -1 to 1. Okay, so we're going to go ahead and take the derivative. This one is, once again, a chain rule. We'd have our outside is e to the x, and our inside is 2x. Derivative of e to the x is e to the x. Derivative of 2x is 2. Taking this, plugging it in, and multiplying across. So our first derivative is e to the 2x times 2. I'd probably write it as 2e to the 2x. Okay. Now we're going to go ahead and set it equal to 0. Okay. So our derivative set equal to 0. 0 equals 2e to the 2x. I would divide both sides by 2. So 0 equals e to the 2x. And now in order to get rid of ln, or e, we ln on both sides. If you go ahead and try and do ln of 0 on your calculator, whoops, this would just be 2x, it will say error. Because you cannot take ln's of zeros and negatives. Okay, so this is an error. So what this tells me is, once again, no information or no values coming from here, okay? Then the other thing we need to go ahead and check is, where does our derivative, where it does not exist, okay? Well, our derivative is 2e to the 2x. If you were to graph this on your calculator, we go through 2, be increasing, something like this. So, is there any problems with this? Any corners, any cusps, any discontinuities, any vertical tangents? No. So since that is true, once again, this gives us no info. So therefore, there's no critical values we just need to go ahead and test our endpoints. Just endpoints. So we do f of negative 1. And so we have e to the 2 times negative 1. So this gives me e to the negative 2, which your textbook will probably write as 1 over e squared. They mean the same thing. I'll take either one. And then f of 1 will be e2 to the first, so e to the second. And if you type those into your calculator, we'd have, this gives me 0.135, and e to the second gives me 7.389. So that tells me this is my min and this is my max. So my absolute minimum is negative 1 comma e to the negative 2. You could also write it as 1 over e squared, either way. And then our absolute max, try and keep your answers as accurate as possible, meaning no decimals, 1 comma e squared. All right. That is example 6. Which leads us to our homework, which is listed here. So make sure you write that down. If you have questions, feel free to message me. Otherwise, have a great day, and I will see you later.